Yes, good morning, students. We start with the lecture number 6 and unit number 1. In lecture number 6, we are discussing about the implementation of KNN model and logistic regression model. We already discussed about the theoretical concept of KNN and logistic regression. What is the KNN and what is the logistic regression and why we use this? Okay, in which category we use the KNN and logistic regression model? Okay, generally we use for whenever we want to create a model on machine learning for the classification purpose, like email spam classification. We already discussed about this example. So we can take the this model, logistic regression and logistic KNN model for the classification model. Okay, so K nearest uh, neighbor, it means KNN algorithm, you can say model. So the KNN or K nearest neighbor algorithm is a simple, powerful method used for the classification and regression task. Okay, whenever we want to make a model for the classification as well as regression task, so we can use the KNN model. In this specific code example, we explain here. Okay, we are using KNN for the classification. Let's break down what are going doing with the KNN detail step by step. Okay, so we firstly we import the modules. First one is import SYS and import matplotlib. Uh, that means this module provide access to the system specific parameters and functions. Okay. We have to design the model. So firstly require the access to the system. Okay, so that's why we import this sys. With the help of this module, we can this module provide to us access to system specific parameters and functions, as well as it's allowed the interaction with the Python interpreter and access to command line argument also. Okay, both are important whenever we deal with the Python programming. Okay, command line argument as well as Python interpreter. And second is import matplotlib. So what is matplotlib? This module is a comprehensive library for creating a static, animated and interactive visualization in the Python. That means you can say whenever we want to visualize the model as a result, so you can use the matplotlib library. Okay. Next thing is ampersand matplotlib inline. Okay, that means enabling inline plots in the IPython. So what is this actually? This magic command is specific to IPython environment like Jupyter Notebook. We already discussed about the Spider, Jupyter, Colab and all. Okay, so there is required the IPython environment. So this is a magic command. It ensures that plots are displayed inline. It means directly below the code cell that produce them rather than a separate window. Okay, so that's why we are using here ampersand in the inline. Okay, next one is importing a specific function like importing matplotlib dot pyplot as plt. Okay, and next one is from sklearn. Sklearn we use here. Sklearn is a library. Okay, sklearn dot neighbors import k neighbors classifier. We are using sklearn. With the help of this, we import the KNN classifier. Okay, so first line is this. What is actually saying this? This is the collection of function from the matplotlib library. Okay, and used for creating a static, animated, interactive visualization in the Python. Okay, second line is actually saying this. This imports the KNN classifier, K nearest neighbor classifier you can say, or you can say k neighbors classifier, which is a k nearest neighbor classifier from the scikit-learn library used for the classification model as we discussed in previous slide. Okay, next thing is creating data arrays. Okay, whenever you want to import the data from outside sources, so you can do this, but here we create the array, data array. So we use here x and y variable. Okay, what is this actually? X and Y. This list, this is the list container, you can say. So this list contain the coordinates of point in 2D space. Okay, 2D space. And what is the classes here? So this list contain the class level 0 or 1. That means you want to classify the range in 0 or 1. You want to classify this model as a result in two forms, 0 and 1. Okay, there are two classes. It means you can say like pass, fail, male, female, like this. Okay, so X is having 4, 5, 10, 4, 3, 11, 14, 8, 10, 12, and Y having 21, 19, 24, 17, 16, 25, 24, 22, 21, 21. And classes for this each point, you can say 421 having 0 category, and 519 having 0, and 1024 0, 417 0, 316 1, 1125 1, 1424 0, 822 1, 1021 1, and 1221 1. Okay, so this is the uh, classes for each point. Next one is preparing data for training. Data, preparing data. As we know, as we discuss about the machine learning, whenever we want to create a machine learning model, must be required training for that particular data, whatever we used. Okay. Here we creating the data array, so must be training required here. And so this is the process. We read the data. Data is equals to list, and zip function we use here, zip x comma y. That means data. Data, what is actually data? This combine the x and y coordinate into a list of tuple where each tuple represent a point in a 2D space. Okay, so x, y are the coordinate. Okay, and data representing the list of tuple, and each tuple represent a point in a 2D space. Now, initializing and training the KNN classifier. So KNN is equals to K neighbor classifier, and neighbor is equals to 5. That means you want to initialize the number of neighbor, is it means 5. Okay, KNN dot fit, we use the function KNN dot fit because we want to fit that KNN classifier on your data and classes. So data comma classes. KNN, what is actually KNN? We already discussed about the KNN. Okay, KNN dot fit data comma classes. That means this trains the KNN classifier using providing the data points and their corresponding class label. Okay, next is predicting the class of new point. So predicting the class, you want to predict for the new point. So new pointer here, new x is equals to x, y new y is equals to 21. New point will be new underscore x comma new underscore y. So we want to predict. Prediction is equals to KNN dot predict function we use along with the KNN for the new point. So we read here, prediction is equals to KNN dot predict of new point. Okay. So what is actually new x, new y coordinate of new point that we want to classify, and new point is a list containing the new point as a tuple, and prediction, that means this uses the trend KNN classifier to predict the class of the new point. Okay, now we want to visualize this data. So visualizing the data using plt dot scatter, we want to visualize that data in the form of scatter form. So plt dot scatter of x plus new underscore x, that means new data point coordinate of x. Okay, y plus new underscore y, comma c is equals to classes plus prediction of 0. Okay, and plt dot text x is equals to uh, new underscore x minus 1.7, y is equals to new underscore y minus 0.7, s is equals to f new point, and classes is equals to prediction of 0, and then plot. So what is actually doing here? Okay, so we discuss one by one. Plt dot scatter, why we use this? This is create a scatter plot, we as we discussed. Okay, so a scatter we use here for the original point plus a new point, the color of points corresponding to their class label. Okay, plt dot text, that means this add a label next to the new point indicating the predicted class, and plt dot show we use for this display the plot. Okay, saving the plot. If you want to save your plot, so you just use this plt dot save fig. Okay, my graph dot png. Okay, plt dot save fig. Why we use this? This saves the plot as an image file name, my graph dot png. Okay, so you see here whatever we discuss in this slide, previous slide. Okay, as a program, and we discuss line by line uh, description. So after that you save it, this program, and you whenever you save it and then you execute this, you will get the result. Okay, you will get the result for the new point, whatever your new point. Here the new point we consider 821. So prediction will be class will be 1 for that particular point, 821, 8 and 21. Okay, and prediction for that point class will be 1. Okay, that is the another point. Okay, whatever you have considered in your data. Okay, like this 12 approx 20 1.5 like this. Okay, so you can, if you want to see the position of our point, you can just observe it. Okay, now yes, linear regression. How to perform linear regression using Python, SciPy, and Matplotlib libraries. The goal is to determine if there is a linear relationship between the age of cars and their speed. We have one of the example. Okay, we want to uh, relate the age of the car and their speed. Okay, and there are two coordinates. We use x-axis represent the age of car and y-axis represent the speed. So let's we discuss each steps in detail. So first one is importing necessary libraries. Okay, import matplotlib.pyplot as plt. Okay, from sci py import stats. So what is actually this? You first one is matplotlib.pyplot as plt used for creating static, animated, and interactive visualization in Python, as we discussed in previous example also. SciPy.stats provide tools for statistical analysis, including function for performing linear regression. Okay, so that's new one here. Second point is defining the data. So as we discussed in previous example, here is also one of the example, x representing the age of car and y representing the speed of the car. For example, first car 5 years old, so maximum speed of this car 99 kilometer per hour, and 7 years old car having the maximum speed 86 kilometer per hour, like this. Okay, so a x is a list of representing the age of car and y representing the speed of car. Third point is performing the linear regression. So slope, intercept. Generally, we use the relationship, linear relationship. That means y is equals to mx plus cu, as we discussed in previous topic. Okay, so slope is required here. Slope, intercept r p std underscore error is equals to stats dot uh, lin regress between x comma y. Okay, so what is actually stats dot lin regress x or y? Perform linear regression. We use for the perform linear regression on your given data. Okay, then it returns slope. Slope of the regression line will be represented by the slope, and intercept of the line. It represents the intercept of the line. And what is R actually? The correlation coefficient. It's indicating the strength and direction of the linear relationship. Okay, and what is actually P? The P value indicating the probability that observed the correlation occurred by the chances. And what is actually STD error? The standard error for the regression, whatever we found. Fourth step is creating a prediction function. So we use def my function of x, okay, and return will be slope multiplied by x plus intercept. Okay, so my function of x is representing the function that include the predicting speed, which is y value, okay, for a given age, which is x value, choosing the slope and intercept of the linear regression line. Fifth point is predicting speed of 10 years old car. Model is ready, but if you want to predict the speed of the 10-year-old car, so we use the my function. Okay, so speed is equals to my function of 10, which means 10 years old car. Okay, speed, what is actually speed here? So the predicting speed for a car that is 10 years old. 6 point is generating the model's prediction value. So my model is used. My model is equals to list map my function dot x, which is actually a list of predicting y value for each x value in the original data set. This represents the x value on the regression line. And plotting the data. Plot dot scatter x comma y. Whenever we want to plot the data, so here's the required some graph pattern. So scatter we use here for x comma y, and plt dot plot x between x comma my model. That means uh, x will be the, you can say, whenever you want to predict 10 years old car, that means it is x. Okay, and my model we use for the, that means you have a model to predict the new value. Okay, for the two coordinate, actually you can say, for example, if you want to relation predict for 10 years old car, so how much speed will be there for 10 years old car, so you can relate with the given model. Okay, so then you want to show, so plt dot show is using here for the displaying your plot. Okay, and eighth point is printing the predicted speed, so we use the print of speed. So that will be print your predicted speed of the 10 years old car. Okay, so that will be your answer. That means 10 years old car speed will be 85.59 kilometer per hour. Okay, so and as well as this is the pictorial representation of the 10 years old car. It's approximate uh, 85 point, this one 85.59. Okay, and that is the, these are all other points representing the other car age. Yes, now we are discussing about one of the example of KNN, how KNN works. So we are using here Colab platform here to execute the program, and we already discussed about the KNN, K nearest neighbor. K, uh, K you can choose as per your requirement. Okay, there is some methods also. Uh, elbow method is so most popular, but you can put it here k value as per your requirement. whenever you want to uh, k is equals to 5, so you can put the k is equals to 5. That means if you want to the class of your new point, new data point, so just uh, you can if you want to the neighbor of the your new point, so you when you put here k is equals to 5, that means your neighbor will be 5. So that means your new point data point will be considered surrounding your minimum distance which are nearest with your new data points, which are only 5. Okay, because we are using the value of nearest neighbor is equals to 5, that means k is equals to 5. Similarly, if you want to put the value of k is equals to 4, so in that case it will be considered only 4 nearest neighbor from that your new data points, okay, surrounding your new data point. Okay, so this is the most popular classification method which is under the category of supervised learning method in machine learning. So let's start. Here we are presenting the program, and we are uh, discussing each of the program line with as a comment like this. Firstly, we import. Uh, Firstly, we import the modules as your need. Okay. Then scikit-learn is the most popular library we are using here, uh, which are uh, which are using in the machine learning in Python for the manipulation purpose of the data, manipulation of the data. Okay, you can say. And next line is 3 lines to make our compiler able to draw. First one is with the help of these 3 lines, starting 3 lines. First one is uh, import sys. Import sys. That means sys. Okay, so what is this sys? So the sys module provide access to system specific parameter and function in Python. What is this? Firstly firstly we want to import all modules as per the requirement, as per your need. Okay, so we want to draw there are some graph also. We want to do your some calculation. We want to do some manipulation is also there. So so we are using here the sys. Okay, so the import sys with the help of these 3 lines, import sys, eh, matplotlib, import matplotlib inline. Okay, so with the help of these 3 lines, we are using here to make your compiler able to draw something. So what is the meaning of this particular line? The sys module provide access to system specific parameter and function in the Python. Provide access to system specific parameter and function in the Python. Whenever you required system specific parameter function uh, in the Python, so you can use this module. It also allow you to interact with Python interpreter and access command line argument. Okay, with the help of this module, we can access the Python interpreter and access command line argument also. Second module is we are using here import matplotlib. Import matplotlib. So matplotlib we are using here for the virtualization purpose. Whenever you want to draw some uh, plot, whenever you want to draw some graphs, so for the visualization purpose you can use this matplotlib. Okay, as well as pyplot is a collection of functions in popular visualization package matplotlib. We are using we can using pyplot here also. Okay, so pyplot, it is the collection of functions in popular visualization package matplotlib. Okay, so matplotlib we are using for the visualization purpose. Next one is matplotlib inline. Percentile matplotlib inline. So this line tells the IPython environment to draw the plot immediately after the current cell. What is the meaning of this? Why we use this? This line tells the IPython environment to draw plots immediately after current cell. So these are the most important line we are using here. Okay. So as we discussed, line by line. Okay. First line, second line, and third line. Okay. With the help of all these three lines, we make your compiler able to draw something. Okay. So next is uh, import matplotlib.pyplot. We already discussed pyplot means what? Pyplot is a collection of function in the popular virtualization package matplotlib. So that's why we are using here import matplotlib.pyplot. Okay, as PLT is a you can create as a object also PLT. Okay, now from sklearn we already discussed. Sklearn is the library, okay, which are using here uh, to work with the nearest neighbor classifier. Okay, so from sklearn.neighbors import neighbor k neighbor classifier. So this is the way, this is the syntax to write whenever you want to import your classifier, any classifier. Okay, so you can use sklearn. Okay, because you want to import your classifier with the help of sklearn library. Okay, got it. So remember all this important uh, line here, all these three line, five line. Okay, so KNN classifier we are importing here. KNN classifier. Remember this thing. Okay, next. There are some uh, data points along with X and Y coordinates. So create arrays that reassemble variables in the data set. We have two input features X and Y. X and Y represent here input features here. Okay. Then target class also there. So this is the target class which will be 0, 1. There are two class only. Okay, so you can see here whenever interact with 421, 421, so that will be in 0 class. Okay, according to your data. 5, 10, according to data it will be in 0 class. And next one is 10, 24, it will be in 1, another class. 417, it will be in 0 class. 316, it will be in 0 class. 1125, it will be in 1. Okay, 1424, 1. 822, 0. 1021, 1 class. 1221, 1 class. Okay, so here is the data. We have two input features X and Y, then target class also. Okay, the input features that are pre-labeled with our target class will be used to predict the class of new data. Okay, so that's you can say here your features, input feature are pre-labeled. Okay, because it's indicate uh, each and every features indicate our own class. Okay, it will be helpful to predict the class of new data. Okay, note that while we have used two input features here, this method will work with any number of variables. Okay, I think you all of you understand this thing. So next, actually this is the comment. Okay, you can see here whenever we use 3 colon, you can see here at the starting and ending. So it will be considered as multi-line comment, and Here we are using single hash. So this is single line command in Python. Okay. Whenever you want to give some command in your program, so you can use this. Okay. So next one is turn the input features into the set of points. Turn the input features into a set of points. Okay. So we want to set all of these points in a single set, that is data is equals to list. We want to zip all of these points, so it will be zip of x comma y. Now we are using here KNN. Okay, we are already imported this classifier k nearest neighbor, k neighbor classifier. Here we are giving the value of n neighbor is equals to 5. Okay, so this is the value of k. Now we want to fit all of these data on nearest neighbor classifier. Okay, so KNN dot fit your data that will be in this. Okay, and classes we want to map from this class. Okay, now okay, now we want to know about your new data point position. Okay, new point is new new point is 8 comma 21. That means new coordinate new underscore x is equals to 8, new underscore y is equals to 21. Okay, so your new point indicated by this, represented by this new point is equals to this. Okay, because this is representing by x and y coordinate. Okay, so we want to predict new data points. So prediction is equals to knn dot predict. We are using our predict function with knn on your new data point. Okay, so plot dot scatter, we want to scatter form of the data. Okay, so plot plt. Okay, this is the object of plot function. Okay, of my matplotlib. Plt dot scatter, which form is scatter form x plus x new, y plus y new, c representing the classes plus prediction. Okay, for 0 it may be 1. Plt dot text x is equals to new x minus 1.7. So we want to subtract some value in the x new coordinate 1.7 and at the new coordinate y new coordinate minus zero point 0.7. This is randomly you can use the value. It may be 1.3, it may be 0.4, because we want to just use here uh, because overlapping might be arise here whenever we want to predict new data point 821. It may be possible here already 821. Okay, so we want here escape the we want to remove here overlapping. Okay, that's why we are subtracting this value from your new point data points. Okay, so as equals to app new point classes prediction. Okay, so this is the syntax to represent. Okay, this is the way to subtract some values from the your new data points. Okay, now plt dot show, we want to display your graph, so that's why we're using here plt dot show. Okay, here now two lines to make our compiler able to draw. With the help of this, we are using plt dot save fig, which name mygraph.png. With the help of this line, you can save your figure in PNG format in your PC. Okay, so with the help of this function, save fig. Okay, sys dot std out dot flush. We are using here flush function to uh, flush your all buffer. Okay, so this is the way to understand how KNN works. Okay, how KNN works. So just execute this program. Whenever you want to start your writing on Colab, so this is your result. This is your result. Okay, so this is the result in a scatter form, and figure size will be here for 640 into 480. Okay, and new point will be here 8, approximate 8, because we remove some values 1.7 from it. Okay, so this is the nearby 8. Okay, so 8 and 21, sorry. Okay, so that will be there. Okay, so this point is this, and after using KNN classifier to predict your new data point class. Okay, so that will be predict the class of new data point on the basis of this data. Okay, on the basis of this data, so it will be class 1, consider as class 1. See here. Okay, so whenever you start your program in Colab, so just open Colab and log in with your email ID, and there are some uh, icon here. Just go with the file and open new notepad. Okay, so here is the notepad, new notepad, just opening here. Whenever you want to open your notepad, start your writing. Okay, start your writing here, and you, if you want to save your program, so just go with this and save a copy in your drive. So it is automatically save in your particular email drive, and whenever you want to use in future, so you just use this program in future. And if you want to share this program immediately with your friends, so just go with the download and download.ipn by manner. Okay, so you can just uh, this method to write the program and download the program and save the program. Okay, so I already shared this program with all of you, and I already saved this program in my PC in my Colab. Okay, so this is the KNN example, and we try to understand here how KNN works. Okay, so let's read out, let's explain again. There is the three important lines here. You can see whenever you want to start your writing, so must be there import some module as per your requirement. Okay, so here we are importing here sys, importing matplotlib and inline also. Okay, import matplotlib.pyplot as plt. Okay, and import KNN classifier from sklearn libraries. Okay, then third step is reassemble your data set. Okay, then your data set, zip your data set in a single list. You can say data. You can see here this data having only 10 items, which are 421, 510, 1040, and 417, 316 as per your data. Okay, so this is the Canon classifier, and with the number of k, number of value of k. Okay, so this is the function there. You can data and class fit on your KNN. Okay, this is the new data point values 8 and 21. Okay, And here we use prediction with the help of KNN. Okay, and PLT dot scalar we are using here because we want to uh, print our figure and scatter manners. Okay, that's why using here scatter. Okay, with the class and with the new data points. Okay, and we want to show your figure, so we are using here uh, show function. Okay, and we want to save your figure, so we using here my graph save figure save fig function here, and we want to flush also the buffer, so we using here flush function. Okay, that's the KNN procedure. Okay, so I hope it is understand to all of you. Yes, next example we want to discuss here regression. So we all know about the regression already. Discuss some example like weather prediction and share price market prediction, age prediction. So let's take an example again, weather prediction. How can we predict the? How can you say uh, your weather in the evening? I think it will be uh, considered as a weather prediction application you can use, and you can identify the temperature, how much temperature in the evening today, and how much temperature in the uh, tomorrow evening, how much temperature in the day after tomorrow evening. How can we uh, identify with the help of any application? How can we do that? With the help of regression, with the help of regression and machine learning. There are so many regression types are here. We already discussed linear regression, multiple regression, polynomial regression, support vector regression. There are so many regressions, but we are discussing here currently linear regression. Okay, so linear regression means what? There is a model we have to create, just like a line, best fit line we have to create, which line lie lie with the most of the data points which are very nearby by the line, and which be lie on your line. So that will be called as the best fit line. Okay, so let's take an example of the linear regression. And how can we say how can we say this is the regression? Because the regression always work with the continuous value. Okay, for example, whenever you talk about the classification, that means you will always set class 1 or class 2. Okay, same as the example we have to discuss in previous KNN classifier. There will be the we want to predict the class of new point. Okay, 821 in your previous example. Okay, so after the execution of your KNN model, KNN model predict the class of that particular point. That will be considered as class 1 or class 0. There is no any country value. There is a categorical value, class 1 or class 2, like useful email and unuseful email. That means you can say ham, spam, pass, fail. Okay, so similarly here is something different, like we are using here the regression and output will be in continual. For example, weather forecasting. Okay, so it is variable form. If you're talking about today's evening, it will be like 30-degree temperature in today evening. Okay, if you are talking about right now temperature, current temperature, it's 4 o'clock right now, so it is 40-degree something. But if you are talking about what will be the temperature at night, today's night, 9 o'clock, so it will be might be 28 degree something. So it is variable, it is changeable. Okay, if you're talking about morning, tomorrow morning, so it will be 26, 21, like this. Okay, if you're talking about uh, tomorrow 12 o'clock temperature, if you're talking about 1 o'clock temperature, so it will be variable, it will be changeable, it's not fixed. Okay, so this is the best example to understand the regression. So similarly, the x-axis represent age here. In the given example, x-axis represent the age and the y-axis represent the speed. We have registered the age and speed of 13 cars as they were passing a toll booth on any highway. Okay, there are age and speed, two features are there, and we have to register the age and speed of 13 cars as they were passing a toll booth. So let us see if the data we collected could be used in linear regression. Okay, so firstly, we import all necessary libraries, all necessary modules. So firstly, we are talking about here, we want to plot something. Uh, I want some figure here. We want to draw some figure here. So we use virtualization package here. So import matplotlib.pyplot.splt. Okay, pyplot is a function. Okay, of matplotlib. Okay, we uh, we create as an object plt. Okay, from scipy import stats. Whenever you want to work with the scientific data, scientific work, so we use here scipy library, and as well as import stats, that means statistical analysis whenever you want to work. Okay, so remember this thing. Okay, next, create the array that represent the values of x and y axis. Create the array that represent the value of x and y axis. So we already said there are two features. X represent the age of the car and y represent the speed of the car. That means you can say first car, there are only 13 cars. First car is 5 years old and maximum speed is 99 kilometer per hour, which were passing one of the toll booth. Okay, and 7 year old car is having the speed uh, 86, and 8 years old car having the speed 87, 7 years old car having the speed 88, 2 years old car having the speed 111, and 17 years old car having the speed 86, 2 years old car 103. Okay, 9 years old car having the speed 87. Okay, similarly, 11 years old car having speed 94, sorry, 78, and 12 years old car having speed 77, and 9 years old car having the speed 85, and 6 year old car having the speed 86. So this is the features, okay, which are the value represent the age and as well as speed of the 13 car. Okay, now execute a method, execute a method that returns some important key values of linear regression. Okay, so the R value range from -1 to 1 here, and where 0 means no relationship and 1 and -1 means 100% related. Okay, so there is one another parameter P. Okay, one is R and second one is P. Okay, so R is the value which having the range from -1 to 1. 0 it means no relationship. 1 and -1 which means 100% related. And next one is P, R and P. So the P value of linear regression model checks if there is significant linear relationship or correlation between your predictor and the target variable. If the p-value is low, the p-value is low, then you can say your relationship is significant. Okay, so we are using here slope, intercept, R, P, standard error, okay, along with stats dot linear regression function for x and y. Okay, understand this line? Okay, these are the key important key values for the linear regression. First one is slope, okay, intercept. We already know about the equation y is equals to mx plus c. So m is the slope, okay, intercept c here, and r is the relationship, p is the significance. Yeah, you can check the significance of your relationship, and standard error, and stats dot linear regression function on x. Create a function that uses slope and intercept value to return new value. This new value represents where on y-axis to the corresponding value x value will be placed. Okay, here we use def my function on x. Okay, and return will be slope slope multiplied by x plus intercept. That means mx plus c. Okay, predict the speed of 10 years old car. If you want to predict, 10 years old car, because there is no mention here 10 years old car how much speed will be there. Okay, so we want to calculate 10 years old car. So speed is equals to my function 10. We put here 10. Okay, run each value of x array through the function. This will result in new array with new value for the y axis. So my model is equals to list map with my function comma x. Okay, because we are using here this list, why we use this for your model, because we want to develop your model. So run each value of x array through the function. This will result in new array with new value for the y-axis. So draw the original scatter plot. So plt dot scatter between x comma y, draw the line of linear regression. So we use here plot dot plt dot plot in between x comma my model, and display the diagram. So we are using here show function and print speed. We want to discuss about speed. We want to predict the speed of the 10-year old car. So we are using here print speed. Okay, just run this cell, you will get the answer this. Okay, so speed is 85.5930 something. So it is the contiguous value. It is representing that if we are talking about 10 years old car like this, you can see here, it will be having the speed approximate 85.59. Okay, this is the line, this is the best fit line of this model, where each of the data point if, where each of the data point lie on that particular best fit line, or it may be nearby on that particular best fit line. Okay, all these data point having minimum distance with this best fit line, or you can say maximum data point will be lie on this particular best fit line. Okay, so this is the linear regression example. I hope you all understand this thing. So once we again explain this program of the linear regression. Firstly, we import all necessary libraries like this. Okay, matplotlib.plt as plt, pyplot as plt from scipy import stats. Okay, then we create the data set. Whenever you don't want to create any data set, so just use uh, existing data set. Okay, next if we are talking about the data set. If you don't want to create any data set, so just you can just import any data set, which are so many data set available in the so many website like UCI, Kaggle. Okay, so there are so many data set available whenever you want to work with the regression as well as classification. Okay, then we have to this equation used here. These are the key important key value of the linear regression. Whenever you deal with the linear regression, that must be required. Okay, so here we want to create our own function. Okay, that uses the slope intercept. We all knows about this equation, y is equals to mx plus c. We already learned this equation in our 10th standard class. So I hope you all know this equation. And this new value represent where on the y-axis corresponding to x value will be placed. Okay, so we created a function here, and we want if you want to predict 10-year-old car, or you can say any other like 15 years old car speed. If you want to know about 15 years old car speed, so you can just put it here 15, and you can know about the speed of the 15 years old car. Okay, then if on then uh, run each of the value of x array through the function, that will be result a new array with new value by axis. My model with this we have to create it. My model is equals to this. Okay, your list is this. Okay, then plot. If you want to draw your model and a scatter plot data points, you can just use scatter function here. Then draw a line. So you just use this plt dot plot x and my model. Then you want to show your speed, so show your diagram or model, you can say. And you are working with the speed, so that definitely you want to print your speed. So after execution you will get the speed of that particular prediction. Then you want to print the 10 years old car speed, so it will be 85.59308 something. Okay,